All right, we're going to do inverse functions today. Inverse functions are very useful in practical application in like real situations. So this is something that's pretty important because if you know that you're shooting a rocket into space and you want to figure out at what time it's exiting radio communication, and you know the way in which the radio communicates, you can resolve that backwards to see at what time you're going to lose it. You're going to lose radio communication. So stuff like that is why we do inverse functions in the first place. So we're going to start with something like f of x equals, I'm going to start very simple, 2x plus 1. Your first step, step 1, is going to be replace f of x with y. Your second step, let me do that. So it's y equals 2x plus 1. You're going to switch x and y. The reason that you're doing that is when you do the inverse of a function, all of the inputs become the outputs, and all of the outputs become the inputs. So you switch their spots. So it's going to be x equals 2y plus 1. But really you want to figure out what value do I input here to get a certain value here. So we're going to solve for y now, and that's going to be step 3. Solve for y. So on this one I'm going to subtract 1. So I have x minus 1 equals 2y, and then I'm going to divide by 2. So I have y equals x minus 1 over 2. Step 4. Step 4. You're going to replace y with, this says the inverse of f of x, but it's written as f to the power of negative 1x. So for this one, I'm going to put f to the power of negative 1x, or inverse of f of x, equals what we had right here, x minus 1 over 2. So that's finding the inverse. I'm going to do a few examples, and we'll do examples in class as well. So if I start with, this time I'm going to start with g of x, so it's going to be just barely different. First, replace it with y, switch the x and the y, solve for y, and then replace it with the inverse of the original function, which this one was g. So that's the inverse function. Do one that's a little bit harder. So if I have something like first, replace it with y, switch the x and y. Now I have to solve it. Remember that our order of operations is PEMDAS. So I got to get rid of addition and subtraction first, because when we're solving, we go in the reverse order. So I'm going to add this 9 first. I don't have any multiplication or division on the outside. I do have exponents, so I'm going to get rid of that. So I'm going to square root. It's going to cancel this. And then I'm going to subtract 2. But that needs to be on the outside of the square root. So it's over here, not underneath. And then I'm going to put my inverse function like that. Now we'll ask if two functions are inverses. Like I'll give you two functions. I'll give you this and I'll give you this, and I'll ask if they're inverses. This is how you can tell. Whatever the input you choose to put in here, any number you want, let's choose any number. I'm going to choose 1. I plug in 1 here and I see what it gives me. So 1 plus 2 is 3. 3 squared is 9. 9 minus 9 is 0. So if I plug in a 1, I get a 0. The inputs become the outputs on the inverse, which means this one should be an input of 0 and an output of 1. And let's see if that happens. 0 plus 9 is 9. Square root of 9 is 3. 3 minus 2 is 1. So it did work. So those are inverses of each other. And you can use any number. I could use 10 here. I could go, well, I don't want to square 12, so well, that's fine. I could use 10. 10 plus 2 is 12. 12 squared is 144. Minus 9 is 130 positive. Whoops. 135. So that means down here, if I input 135, I should get 10. And let's see if that happens. 135 plus 9 is 144. Square root of 144 is 12. 12 minus 2 is 10. So it did work. So they are inverses of each other. So that's how we're going to check. And that's it.